So let us now solve sample problem number 1 to discuss more about one-way slab. Design a one-way slab having a simple span of 3 meter. The slab is to carry a uniform live load of. So our given live load, edit lang natin yung nasa module. So the given live load in this problem is 7.597. So meron daw tayong live load na 7.597. 7.597 kPa. Assume F prime C is equals to 27.6 megapascal. Fy is equals to 276 megapascal for main and temperature bars. So we're going to use NSCP 2015. So i-design natin yung given na slab na yan. So we're going to design the main reinforcement natin at saka yung yung temperature reinforcement natin sa mga bars natin. So for this one, we're going to consider a 1 meter strip dito sa shorter span natin. So we're going to consider 1 meter strip here. So first, so let's compute for your minimum slab thickness. So kung titingnan natin etong shorter span natin, it is only simply supported. Simply supported lang yung span natin. That's why yung gagamitin natin dito na formula for the thickness that is L over 20. Kaso nga lang, yung Fy natin, it is not equal to 420 megapascal. So kapag meron tayong 420 megapascal, di ba, yung dapat na H minimum natin dyan, o yung minimum thickness of your slab, that is L over 20. Kaso nga lang, since hindi 420 megapascal yung Fy natin, mag-multiply tayo ng 0.4 multiplied by Fy over 700. So if we were going to use that formula, makakompute na ngayon natin yung minimum thickness of your slab. So let's compute for the minimum thickness. So meron tayo dito na L natin, that is 3 meter. So gagawin natin yung 3,000 millimeter over 20 multiplied by 0.4 plus yung given natin na Fy na 276 megapascal over 700. So you will have a value of your H minimum which is equal to 119.14 mm. So gagawin natin is round up natin since dimension naman yan. So gagawin natin yung 120 mm. So yung according to ACI code, yung minimum thickness natin, that is 100. So pasok naman siya din sa minimum. So we're going to adopt the 120. So after natin makompute yung thickness, hanapin naman natin yung effective depth natin. So yung effective depth natin, that will be D. So gagawin natin yan is yung nakuha nating thickness ng slab natin, which is equal to 120. Minus natin yung covering natin, na usually that is 20 mm. Ito yung natin, covering natin from, ito yung concrete cover natin, minus yung kalahati ng bakal natin, which is equal to 12 mm. So kalahati ng 12 mm or yung diameter ng bars natin. So you have a value of your D which is equal to 94 mm. So kung natin yan, kung i-draw natin yan, so diba, we consider a 1 meter strip dito. Nag-consider tayo ng 1 meter stream. So if we were going to draw that one, so pag ganito yan, so yung B natin dito, that is equal to 1 meter strip or 1,000 mm. Tapos, this will be your total thickness or yung H. Sabihin na lang natin T. Tapos, meron tayo dito na main bars. So, this is yung nasa shorter span natin, okay? So, meron tayo dito main bars. So this is illustrated by eto. So this is your main bars here. So kung ano i-shade natin, this is your main bars. So from the center of your reinforcement, the outermost fiber, this will be your D. So dito usually yung concrete cover natin, that is 20. Minus yung kalahati ng main diameter natin, which is 12. So usually yung main diameter natin, that is 12. Tapos yung mga temperature bars natin, nakalatag siya sa taas ng mga main bars natin. So etong red, this is our temperature bars. So this is your temperature bars. So after natin ma-compute, so this is your main bars natin. This is your main bars. So this is 12 mm usually. And then yung ano naman natin, yung mga temperature bars natin, which is denoted by yung red natin. So this is yung mga temperature bars. So this is 10 mm naman. So for this one, kapag na-compute na natin yung value ng D natin, hanapin naman natin yung weight ng slab natin. So what will be the weight of your slab? Or yung weight ng slab natin, that is yung unit weight of concrete, which is usually unit weight of concrete multiplied by thickness. So yung unit weight ng concrete natin, so that is 23.5 kilonewton per cubic meter multiplied by yung thickness natin, which is equal to 120 mm. Kaso nga lang gagawin natin yung meter, kaya 0.12 meter. So the weight of your slab in terms of kPa is now equal to 2.82 kPa. So after nating ma-compute yung thickness ng weight ng slab natin, let us now calculate for the value of your factored floor pressure. So hahanapin ngayon natin yung factored floor pressure natin. So with that, gagawin din natin is, paano yan? So since NSCP 2015 tayo, that is 1.2 dead load plus 1.6 live load. So for this one, meron tayong given na dead load, yung na-compute natin na 2.82 or yung weight ng slab natin, plus 1.6 which is yung given natin na live load dun sa problem na 7.597 kPa. So we have a value of your factored floor pressure which is equal to 15.539 kPa or kilonewton per meter squared. So magko-consider tayo dyan, kung i-multiply natin yan by 1 meter strip, so mangyayari niyan is yung W mo, so that will be, kasi eto na-consider tayo ng 1 meter strip, so mag-multiply tayo dyan, so magiging 15.539 kilonewton per meter. So that will be the value of your factored uniform load. So after natin ma-compute yung factored uniform load, let us now calculate for the value of your maximum factored moment or denoted by MU max. So hanapin ngayon natin yung MU max natin. So yung MU max natin, mako-compute natin yan referring to the loadings. So kung titingnan natin yung yung shorter span natin, that is a uniformly distributed load. So for uniformly distributed load, that is WL squared over 8. So yung WU natin, that is 15.539. Yung L natin, that is 3 squared over 8. So you will have a value of your MU max, which is equal to 17.481 kilonewton meter. So after natin ma-compute yan, so yung gagawin natin is yung MU max natin, diba? That must be less than or equal to the M capacity. So pag-equate natin yung dalawa para makuha natin yung value ng raw natin o yung actual still ratio. So yung value natin dito, yung M capacity natin, that is equal to reduction factor, nominal resistance BD squared. Or kung tawag dito is i-decongest natin yung R sub n, that will become reduction factor rho Fy BD squared 1 minus rho Fy over 1.7 F prime C. So kung sa-substitute natin yung mga values natin dito, meron tayong given dito na na-compute na 17.481 kilonewton meter. Gagawin natin siyang Newton mm. So mag-multiply lang tayo ng times 10 raised to 6 is equals to, so yung reduction factor natin dito, that is 0.90 rho. Yung Fy natin, that is 276. So that will be 2.276 multiplied by yung B natin. So ito yung 1000 mm multiplied by yung D na na-compute natin, which is equal to 94 multiplied by 1 minus rho multiplied yung Fy natin na 276 multiplied by 1.7 na F prime C. So yung F prime C natin, that is 27.6. So yung value ng rho natin by shift solve is now equal to 0.00838. And after that, we're going to check the ductility. So solve natin yung value ng rho minimum natin. So for this one, so solve natin yan, compute natin yung 1.4 over Fy natin. So that will be equal to 0.0051. So which is, etong rho minimum natin, that is less than to the value ng rho actual natin. So meaning to say, okay siya. After natin ma-compute siya, let us now solve for the value of your rho max. So we are going to assume na tension control tayo dito. So we have a value of your 3 over 8. So multiplied by 0.85 F prime C beta over Fy. So yung beta natin, that is 0.85 kasi nga yung F prime C natin, that is only 27.8 megapascal. Hindi niya na-exceed yung value ng limiting value natin na 28 megapascal. So if you're going to substitute yung mga values natin, that is 0.0271, which is greater than to the value of your rho. So meaning to say, okay tayo dyan. So meaning to say, ductile failure tayo. Since the value of your rho is nakapagitna siya to the value of your rho minimum and to the value of your rho maximum. After natin ma-compute kung ductile ba yung failure, let's solve for the value or for the spacing of your main reinforcement. So let us now solve for the spacing of your main bars. So nakuha na natin yung value nung rho natin. So for the next step, hanapin na ngayon natin yung value ng AS natin and the value ng spacing natin. So for this one, makukuha natin yung value ng AS natin, that is rho PD. So yung nakuha nating rho kanina na 0.00838, i-multiply natin yan to the value of your B, which is equal to 1 meter strip, kaya 1000 mm multiplied by D na 94. So you have a value of your AS, which is equal to 787.72 mm squared per 1 meter strip. So for this, para makuha natin yung spacing natin, so gagawin natin is yung AS natin over sa 1,000, i-ratio and proportion natin siya to the diameter ng isang bakal over yung spacing niya. So you will have yung AS natin na 787.72 over 1,000 equals yung area ng isang bakal natin, that will become pi over 4. So that will be 12 mm squared over S. So by shift solve, we can now calculate for the value of your S, which is equal to 143.58 mm. So kapag sa spacing, since ano tayo dito, dapat sa pag spacing, round down tayo dyan. So that is 140 mm. Kapag dimension, round up naman. So kapag nakuha natin yung spacing, we're going to calculate for the value of your maximum spacing naman required by the code. S max, that is equal to 3H. So 3 multiplied by 120, so you have 360 mm. Or yung ano natin dito na 450 mm daw. So, we will going to choose yung smallest value natin within the 3, among the 3. So, you have 140, 360, 450. Therefore, S is equals yung smallest natin na 140 mm. On center, 12 mm diameter main bars. After nating ma-compute yan, let us compute for the value naman ng temperature bar naman natin or yung AST at saka yung spacing niya. So for this, since ginamit natin is 276, so under tayo sa grade 275. So gagamitin natin value ng AST natin, that is 0.002 BH. So that will become 0.002 multiplied by 1,000 or yung 1 meter strip natin multiplied by 120. So you will have a value of 240 mm squared. So parehas lang tayo ng gagawin. Magre-ratio and proportion lang tayo over 1,000 equals dun sa area ng isang bakal over yung spacing niya. So we have AST na 240. So over 1,000 is equals to yung area ng isang bakal natin. That is 10 mm over S. So the value of your S is now equal to 327 mm. So sabihin natin dapat divisible by 10. So sabihin natin na 320 mm siya. After natin ma-compute yung S, so meron tayong given na value ng S max natin, which is denoted by 5H. So 5 multiplied by 120. So you will have a value of 600 mm or yung isa pa natin na 450 mm. So we will going to use na S ng temperature bars natin, yung smallest value among 320, 600 at saka 450. So we're going to use spacing of 320 mm for our 10 mm diameter temperature bars. So ganun lang yung pagde-design natin ng one-way slab.